Now, the Great Pyramid of Giza is probably the most stunning of all these ancient structures. And the stones are immense, and some of them were cut from a quarry that's hundreds of miles away.
Well, some of them, the granite in the Great Pyramid comes from more than 500 miles to the south. If you look at the famous King's Chamber, its walls and its roof are, the ceiling of the King's Chamber are all made with gigantic granite blocks.
Stunning detail.
What if everything we've been told about ancient Egypt's tools is only part of the story? Deep inside Egypt's granite quarries, Graham Hancock came face to face with something that didn't just raise questions, it challenged history itself. The stone didn't look crudely carved, it looked engineered. Smooth, curved grooves ran through the rock with a level of precision that feels almost impossible, like they were shaped by a high-speed machine, not simple hand tools. For years, these marks were dismissed as primitive work. But Hancock saw something different. To him, these weren't just cuts in stone. They were clues pointing to a lost technology, something far more advanced than what mainstream history accepts. The mystery deepens inside the Egyptian Museum, where an unfinished granite sarcophagus sits silently among ancient relics. At first glance, it seems ordinary, but look closer, and everything changes. Carved from a single block of red Aswan granite, its interior shows tool marks that are incredibly smooth, perfectly aligned and shockingly uniform, more like modern machining than ancient craftsmanship. And yet, according to conventional archaeology, this object was created over 4,000 years ago, using nothing more than copper tools, wooden hammers, and sand. So the question is, were the ancient Egyptians really working with simple tools? Or are we missing a much bigger piece of the puzzle? For Hancock, that claim raises a serious problem. How could a civilization without iron or steel precisely carve one of the hardest stones on Earth? Granite ranks around 6 on the Mohs hardness scale, while copper sits at roughly 3. In simple terms, copper shouldn't be able to cut granite. It can barely scratch it. But the inside of this sarcophagus tells a very different story. Deep, symmetrical curves and sharp right angles suggest rotary cutting, possibly even machine-like drilling. Fine circular striations form spiral patterns along the interior surface, exactly what you'd expect from a fast-spinning tool. These aren't random chisel marks. They're consistent, controlled, and precise, like cuts made by modern core drills. When engineers tried to recreate these marks using copper tubes filled with quartz sand, as Egyptologists suggest, the results fell short. Even after hours of effort, they could barely cut a few millimeters. At that rate, completing something this precise would have taken an enormous amount of time, far beyond what seems practical. So maybe the real mystery isn't just how it was built, but what we've overlooked all along. If you love uncovering hidden history and ancient mysteries like this, make sure to subscribe and turn on notifications, because the truth might be far more advanced than we've ever imagined. The level of precision and efficiency simply didn't match the tools that were supposedly available. Hancock wasn't alone in questioning this. Chris Dunn, a British engineer, studied similar artifacts and closely analyzed the spiral patterns left by the drills. His findings pointed to an unusually high drilling speed, far beyond what could be achieved with hand-powered copper tools. To produce those results, the tool would have needed steady rotational force, something consistent, controlled, and likely powered. Possibly even a form of mechanical or vibrational technology that hasn't been recognized by mainstream archaeology. If that's true, it changes everything. It would mean the builders had access to a level of precision engineering far beyond what we've been told. Some researchers argue that ancient Egyptians used bow drills or tubular drills with hard abrasives, but even those explanations fall short when you consider the flawless curves and polished inner surfaces. The accuracy is just too high. What makes this sarcophagus even more intriguing is that it was never finished. It's like a snapshot frozen in time, capturing the process mid-work. Instead of hiding the method, it exposes it, offering a rare glimpse into how it was being shaped. For Hancock, this wasn't just an anomaly. It was the beginning of a much bigger mystery, a sign that the accepted narrative might be incomplete. Determined to dig deeper, he turned his attention to the drill holes themselves, because if any trace of this lost technology remained, it would be there. Back in the early 1980s, researchers at the University of Pennsylvania Museum began studying Egyptian stonework using modern scientific techniques. Their focus was on drill holes found in granite and basalt artifacts across sites like Giza Plateau and Aswan. Instead of speculating, they took a more precise approach. Silicone molds were made from the drill holes and the stone cores extracted from them. These molds captured every detail, the exact shape, texture, and pattern, allowing scientists to examine them under microscopes without damaging the original pieces. What they discovered only deepened the mystery. The drill marks revealed perfectly uniform, concentric ridges wrapping around the cores. These weren't irregular scratches caused by uneven hand pressure. They were consistent, controlled, and highly refined, pointing to a method that still doesn't fully fit the tools we believe existed at the time. What made the findings even more astonishing was how the spacing between those ridges wasn't constant. It subtly changed along the length of the hole. That detail suggested something crucial. The drill's speed or pressure was being adjusted during the process. In today's manufacturing world, that level of control requires machines that can maintain steady torque and precision, not something you'd expect from simple hand tools. Another breakthrough came from the structure of the holes themselves. They weren't solid all the way through. Instead, the molds revealed hollow centers, proving that the ancient Egyptians were using a tubular drilling method. In this process, a hollow tube cuts into the stone, leaving behind a cylindrical core. It's a technique widely used in modern engineering, but officially, it wasn't developed until the 19th century. The idea that this method might have existed over 4,000 years ago directly challenges everything we think we know about ancient capabilities. When researchers calculated the drilling speed using the spiral patterns, the results were shocking. The data suggested the drill advanced nearly 0.1 inch with each full rotation. In simple terms, every turn of the tool cut 1/10 of an inch into solid granite, even by modern standards. With diamond-tipped equipment, that's a significant rate. Copper tools, even when combined with abrasive sand, simply shouldn't be capable of that without bending, overheating, or breaking down. Microscopic analysis added another layer to the mystery. The grooves weren't random, they followed a steady, rhythmic pattern. There was no sign of wobbling, slipping, or uneven force. That kind of consistency points to a stable, continuous power source. Something beyond human hand pressure, possibly a weighted system or a rotating mechanism. And this wasn't a one-off anomaly. The same patterns appeared across multiple drill cores found at different sites, suggesting a repeatable, standardized method, not trial and error. Over the years, researchers have tried to recreate these results using copper tubes and quartz sand, just as traditional theories suggest. But none have come close. Even with modern replicas, the outcome is rough, inconsistent, and painfully slow. After hours of effort, only shallow, uneven cuts are produced. Nothing like the smooth, sharply defined interiors seen in the ancient examples. That gap between theory and reality pushed both scientists and independent researchers to focus on a critical question: what tools were actually used? Archaeologists have uncovered several types of ancient Egyptian tools, including copper tube drills, bow drills, dolerite pounding stones, and abrasive sandstone blocks. These are considered the standard toolkit used during Egypt's Old and New Kingdoms to shape hard stones like granite, quartzite, and basalt. But when tested under controlled conditions, these tools fail to replicate the precision seen in real artifacts. To explain this, some researchers suggest the Egyptians may have relied heavily on abrasive materials, such as emery, corundum, crushed quartz, or sandstone slurry, mixed with water. In theory, these abrasives could grind the stone while the copper tool acted as a guiding frame. This method works reasonably well on softer stones, but granite and basalt are far tougher. The abrasives would wear down quickly, and the copper would deform long before producing deep, clean cuts. Another idea proposes that the Egyptians embedded hard mineral particles directly into their drill edges, essentially creating an early version of a modern composite cutting tool. If true, this would mean tiny crystals of quartz or corundum were fixed into copper or wooden drills, forming a primitive but effective cutting surface. The problem? No physical evidence of such tools has ever been found. No preserved drill bits with embedded abrasives exist in museums or excavation records. The theory is based entirely on the marks left behind on the stone. For Graham Hancock, that absence is suspicious. He argues that if copper tools were truly used on such a massive scale, we should have found more worn or broken examples by now, especially given the number of granite sites across Egypt. Instead, most discovered tools are small and seem better suited for softer materials like wood or limestone. Hancock suggests a different possibility, that the real tools may have been made from materials that didn't survive, like hardwood structures coated with abrasive compounds or stone-based devices reinforced with unknown binding agents. Some engineers have also looked at the mechanics behind the process. To achieve the depth and precision seen in these drill holes, the motion would have needed to be stable and continuous. One theory involves weighted drilling systems, where a fixed load applies constant downward pressure while the tool rotates, similar in principle to an early lathe. While no actual ancient lathe has been discovered, Egyptian artwork does show craftsmen using ropes, bows, and pulleys to rotate tools. This suggests they understood the basic mechanics of controlled rotation. Even so, modern reconstructions based on these ideas still fall short. They produce uneven grooves and inconsistent hole shapes, nothing like the flawless symmetry of the ancient originals. This ongoing gap continues to puzzle experts and fuels Hancock's belief that Egypt's builders may have had access to techniques inherited from a lost or forgotten technological tradition. To truly understand how advanced this method might have been, we need to look beyond individual artifacts and examine where these techniques were used on a massive scale. The strongest physical evidence lies in the granite quarries of Aswan, a region that supplied the stone for Egypt's temples, obelisks, and colossal statues. Some of the largest and most ambitious stoneworks in the ancient world began right there, carved directly from the bedrock itself. The most iconic feature of these quarries is the unfinished obelisk, a colossal structure still partially fused to the bedrock of Aswan. Historians believe it was commissioned by Hatshepsut around 1478 BC. Had it been completed, it would have reached nearly 42 meters in height, about 137 feet, and weighed close to 1,200 tons, making it far larger than any obelisk ever erected in Egypt. But something went wrong. A crack formed during construction, forcing the workers to abandon it where it lay. And in doing so, they left behind something incredibly valuable, a frozen moment of the quarrying process itself. The trench carved around the obelisk reveals a series of long, parallel grooves etched into the granite. These marks aren't chaotic or scattered. They follow smooth, consistent paths, almost as if guided by a controlled tool rather than created through random hammering. The standard explanation is that workers used dolerite pounding stones, hard, rounded tools designed to chip away at granite. In fact, dozens of these stone balls have been discovered at the site, reinforcing that theory. But when you look closer, the explanation begins to fall apart. The trench surrounding the obelisk is narrow and confined, leaving very little room to swing heavy tools with force. Repeated impacts in such tight quarters would also risk shattering the pounding stones themselves. It's a scenario that doesn't quite match the physical evidence. This contradiction led Christopher Dunn to take a deeper look. In his research, he pointed out that the surfaces inside the quarry aren't rough or uneven, as you'd expect from repeated impacts. Instead, they appear smooth and scooped, more like the result of controlled abrasion, similar to what a modern cutting wheel or grinder would produce. Some of the grooves even curve beneath the obelisk, creating undercut sections, features that would be nearly impossible to achieve with handheld pounding tools alone. Dunn concluded that these markings suggest a more controlled force at work, possibly involving rotation or vibration. According to him, even with modern equipment, reproducing those same curved patterns would require tools capable of steady torque and precise directional control. Graham Hancock agrees with this perspective. He believes these marks may point to a forgotten or underestimated technique, evidence that ancient craftsmen possessed a level of technical ability far beyond what is harder assumed. Mainstream Egyptologists, however, remain cautious. They argue that repeated hammering combined with abrasive sand could eventually create such patterns over time. Still, even within conventional research, the Aswan quarry raises difficult questions. Why are the grooves so uniform? Why do some surfaces appear polished instead of fractured? And how could workers shape a 1,200-ton block with such consistency using only simple tools? For Hancock, these inconsistencies are more than just curiosities. They're clues. He sees them as traces of a lost technological system, suggesting that Egyptian builders may have been continuing a tradition that already existed before them. This idea gains even more weight when similar precision appears far beyond Aswan, in temples and pyramids stretching from Giza Plateau to Luxor. Hancock's central claim is bold but simple. The advanced stonework seen in ancient Egypt didn't originate there. Instead, it was inherited from an earlier civilization, one that may have existed before the end of the last ice age, around 12,000 years ago. According to his theory, this unknown culture developed highly refined engineering techniques, which were later passed down to emerging civilizations like Egypt, Mesopotamia, and the Indus Valley. In this view, the Egyptians weren't the inventors of precision, stone cutting. They were the inheritors of knowledge whose true origins had already faded into history. He points to similarities across distant parts of the world, from the granite quarries of Aswan to the stone platforms of Pumapunku, and even certain monolithic temples in India. Researchers have identified comparable tool marks, deep circular cuts, tightly fitted joints, and surfaces finished to near modern precision. These locations are separated by vast distances and timelines, yet they share strikingly similar characteristics. To Hancock, that consistency hints at a shared engineering tradition, one that predates recorded history. Importantly, he doesn't necessarily claim the existence of futuristic machines. Instead, he suggests that this lost knowledge may have involved advanced understanding of abrasives, pressure, and geometry, methods that later civilizations preserved without fully understanding. Over generations, what was once science may have turned into ritual. Ancient builders might have followed inherited instructions, passed down through myth or tradition, without knowing the original principles behind them. This could explain why Egyptian craftsmen achieved extraordinary precision without leaving behind complex machinery. Of course, not everyone agrees. Egyptologists and engineers argue that there's no solid evidence for a pre-Egyptian advanced civilization. They maintain that ancient builders achieved their results through patience, manpower, and clever use of simple tools and abrasives like quartz sand. Yet even within mainstream research, there's an acknowledgement that certain tool marks, especially those on granite cores and in the Aswan quarry, don't fully match what copper and sand alone should be capable of producing. That unresolved gap keeps the debate alive. For Hancock, that gap isn't a problem, it's the answer. He believes it represents the lingering evidence of a forgotten era when builders had mastered techniques we still don't fully understand. For a long time, this discussion remained largely theoretical. But more recent scientific investigations into granite cores and quarry marks have started to bring new data into the conversation, challenging both sides. And perhaps the most compelling evidence lies hidden beneath the sands of Saqqara. Deep underground, the Serapeum of Saqqara stretches through solid limestone, a vast subterranean complex housing enormous granite boxes, so massive and precise that even modern engineers are left in awe. Each of these boxes weighs around 70 tons and is carved from a single block of black granite. According to traditional history, the site dates back to the reign of Khemweset in the 13th century BC and served as a burial place for sacred Apis bulls. But when researchers like Graham Hancock, Christopher Dunn, and others examined these structures up close, they saw something that didn't quite fit the conventional explanation. The surfaces of these granite boxes are extraordinarily precise, far beyond what would normally be expected from ancient craftsmanship. When Christopher Dunn tested their accuracy using high-precision instruments, what he discovered began to challenge everything we thought we knew about ancient stonework. For Graham Hancock, that conclusion is clear. The evidence of advanced ancient technology isn't hidden. It's literally carved into the stone. So what do you think? Could this be proof of a lost civilization, or is there still an explanation we haven't fully understood yet? Thanks for watching, and I'll see you in the next one.